let's try to do the same for a fungible token. Just gonna go back to the contract and copy this endpoint and try to create a fungible token. We're gonna use issue fungible. Let's see what kind of parameters we have here. So alright, we also have to give it an initial supply, because when we create a fungible token, we also create a quantity for it, and afterwards we can add quantity to what we already have. So let's go with the fungible token properties default, and let's give it an initial supply parameter. Alright, it should work. Yeah. As always, we have to rebuild the contract. And also regenerate the proxy. So now if we check the proxy, we have issue fungible token ID. Cool. We do the same thing. We copy the interaction function. And we're going to call it fungible token ID with another parameter of initial supply. Alright, call the other endpoint. From initial supply. Alright, so this should be our interaction function. Let's try to test it out. With our current setup. Issue fungible token ID. And let's think about an initial supply. Let's say 100. Alright. Now let's run the test again, see if it works. Okay, so it seems like our issue fungible test failed. Let's try to see why. Argument decode error, too few arguments. Right, so let's check out the takes hash. So this is a transaction, and let's check out the logs. Okay, upgrade properties. So this is the setup phase for the token. Issue seems to be okay, and we have an error on the callback. Yeah, so there's an error in our callback, specifically argument decode error, too few arguments. Okay, so what we can understand from that is that the issue token action is actually successful, but our callback is faulty. So let's check it out. Our callback basically expects the token identifier to be returned by the issue function. So this might be the problem, because the too few arguments error means that it sends less arguments than we expect. So that means that actually this function sends no argument, and that actually makes sense, because in the case of fungible tokens, we can already mint an initial supply, and the initial supply is sent to us. So the contract doesn't send a token identifier as a data type, but we can get the token identifier from the transfer. So let's try to build a new callback and see if that was actually the issue. So let's call it issue fungible token callback. Very specific, it's always the best. So for the call result type, we are going to give it a unit type, which is basically nothing. It's the way we say nothing. And now we're not going to have any token ID here, but we know that we will receive a payment. So we're going to use something from call value, which is eGold or single fungible USDT, which is going to return eGold or USDT token identifier and an amount. We expect it to be an USDT token identifier, so we are just going to unwrap this token identifier as USDT. We're just going to leave this unused, and let's try to use this callback. So basically the difference is that we do not expect the token identifier to be returned as a data type from the contract, but we actually expect these tokens, being fungible tokens, to be returned as payment. And then we gather the payment that's coming, and afterwards we check the payment and set the token ID. Okay, let's see if that works better. So issue fungible token ID. Let's say we're going to use the issue fungible token callback, and of course rebuild, regenerate the proxy. Okay. In theory we shouldn't necessarily have to regenerate the proxy now, but just a good measure. And now let's try to run the test again. Okay, so this time our test passed. We can check out the takes hash as well. So we confirm this works. Yeah, successful transaction with the logs, upgrade properties, completed event. This is exactly what we are looking for. ESDT transfer from the system smart contract to us, and then set in storage. Yeah, so that's how you can issue tokens from a smart contract using the Rust interactor. Just remember, with the ESDT tokens it's a bit different. You receive a payment with the initial supply of tokens. Oh wait, let's run again and actually check the contract to see if we have everything in storage. Okay, so our test was successful again, and we should have 100 tokens in the contract. First, let's search for the tokens. Yeah, so this is the token that we created, and there was a transaction for 100 tokens, which is the initial supply, that was transferred from this address to, which I assume is our contract. Yeah, our contract's address, and you can find them at ESDT tokens.